Alo Tâm, các bạn vào chưa Tâm ơi? Bằng hình để trong chat. Anh nghe, em nghe không? Rồi, rồi ok. Quay ha. Những buổi nào online thì mình phải quay để upload đó. Ok. Okay. Good afternoon, everyone. Today I am busy, so we have the online class. So I just reiterate the homeworks to all of you. Okay, we have homework of lecture 1 and we have homework of lecture 2. Maybe just part 1. Okay, so and then please submit your thought about binary GA. Okay, using 2-point crossover operator and uniform crossover. Okay, so as I mentioned before, we should revise or modify the MATLAB code of binary GA using the 2-point crossover operator and uniform crossover. Yeah. Okay. Yeah. And the deadline is 15th of December. Okay. If you already did it, okay, just use VGG Moodle and submit your homework. Okay, and we also have this homework of lecture 1. Okay, yeah, because we already finished lecture 1, and remember to submit your homework. Okay, and the deadline is also for 15 December 2025. Okay, and now we continue to study lecture 2, and we hope we can finish lecture 2 for today. Okay, so for now we have the timetable. Okay, ECE, let me see, ECE 2023. Yeah, and we have the online class today. Okay, and of course we have teacher assistant Miss Tam. She will help you to correct the MATLAB code if you have any problem. Okay, you can ask her when I finish the theory. Okay. Yeah, and now we also discuss a little bit of the project. Okay, so because the deadline is 28 November. Okay, so now I will lock. Okay, the digits and you cannot register anymore. Okay, yeah, and we fix. Um, yeah, we fix um, the list of uh, students here. Okay, so totally we have eight groups. Okay, and yeah, as I mentioned before, so for this week you can receive the topic. Okay, so you should spend some time to research the topic I give you. Okay, and next week we will discuss about how to do the cost projects. Okay, what kind of optimization methods you can choose. Okay, so um, but in general, yeah, I will give you some information about cost projects. Okay, so you can receive some papers. Okay, talking about the optimization method. Okay, yeah, and all students in the same group should discuss together how to um, how to understand the objective function. Okay, how to get the same result with the papers I gave you. Okay, and then every members in the same group should pick up one new optimization methods. Of course, I will give you the list of optimization methods, and then every members in the group must pick up one new optimization method and then run the objective function again with the new optimization methods, and then you compare your result with the result from the papers. Are there any difference? Are there any observation? Okay, are there any improvement or advantage or disadvantage between the optimization methods from the papers and the optimization methods you selected? Okay, of course, next week or maybe it's, this week I will give you the list of the new optimization methods. Okay, can you get my point? Yeah. Um, okay, so it's just a very brief description about the topic of the course project. And then if you haven't registered the course project, doesn't mean you reject to get 15%. Okay, with 50% boys. So that means the final exam you try to get 50% boy. Otherwise, you will fail this course. Okay, I mentioned to you many times, right? Okay, we have the course project 50%, final exam 50%, and we have some extra boy to 20%, and the deadline is over. Okay, yeah, that means if your name uh, is not listed here, that means you lost 50% of the total score for this course. Okay, you understand? And of course, for the online class, Miss Tom will make a recording and upload into this YouTube channel. Okay, I have a YouTube channel. Okay, and later on, I will ask Miss Tom to upload the online video. Okay, the video into the channel. Okay, so yeah, now we um, continue with lecture 2. Of course, we are doing the course with math lab. Okay, we have many got. So again, you need to understand the general flow chart of the optimization method, And then you can use ChatGPT or you can use any AI platform, try to analyze, try to understand, try to generate your code. Okay, of course we use MATLAB language. Okay. Okay, so for now, so for last week we already finished binary GA. Okay, so now we can review a little bit. Okay, so what is binary GA? So you can see here we have this solution, right? So we need to convert the solution. This is a decimal, right? This is decimal. So we need to convert to binary. Okay, decimal. Yeah. Maybe it's wait some minutes. Okay. Yeah, I move to here. Okay. So what? So Tom, can you see my slides? Oh, sorry. Okay, so stop sharing. Where you are? Okay, in Thai. Okay, so you see it? Tâm có thấy màn hình chưa Tâm? Okay, so we convert decimal to binary. Okay, binary. So here, we have the set function in the MATLAB how to convert a decimal solution into binary solution, and then we apply crossover. Okay, we have three kinds of crossover operators. They are one boy crossover, two boy crossover, and uniform crossover. Okay, yeah, and we already study one boy crossover. Okay, so for the homework, you continue to write the MATLAB code with two boy crossover and uniform crossover operators. After that, we go to mutation. Okay, mutation. Okay, so you can choose any bit to make mutation. For example, here if you choose bit 0, and when we mutate you can get 1, and the other we just keep. Okay, yeah, after that we make evaluation. We compare whether the new solution is better than the old solution or not. If yes, okay, we update the population. Okay, we update the population to become the new population, and then come back. Okay, just we need, so we finish one iteration, and then we come back to the first step, and then repeat. Okay, until we get the maximum iteration. You can stop and you can get the best solution. Okay, yeah, so this is the general flow chart of GAs. Okay, so now we go to session 2.3. We discuss GA with real parameters. What does this mean? Real parameter, that means we don't need to convert decimal solution into binary solution. We don't need to do that. Okay, yeah, why? Because if we use a binary GA, we have some disadvantages. Okay, some difficulties. Okay, and one of the difficulty is the accuracy errors, because it depends on how many bits for the conversions. Okay, 12 bit, 16 bit, 24 bit, or blah blah blah. Okay, so yeah, this is a disadvantage of binary GIS. And then if you use more bit to make the conversion, you take a long time. That means the computations is longer. Okay, so we think about, we use GA with decimal parameter, with real parameters. Okay, look, the binaries present several difficulties when they are are in the optimization, okay, of a continuous cost function, and consider fixed coding schemes to represent all decision variables. Okay, yeah. The mutation and crossover operations are directly controlled or manipulated through real parameter values. Okay, yeah, and of course we don't need to use the conversions between decimal to binary and vice versa. Okay, so if we use G8 with real parameters, it allows to evaluate directly a candidate solution, the possible solution, in terms of the cost function. Okay, yeah. Advantage of GA with real parameters. Okay, so crossover and mutation operation are such mechanisms easy to visualize and understand. Okay, in binary context. Okay, yeah. So now we have more crossover operators if we use GA with real parameters. Okay, so the first one is linear crossover. We have the population, right? For the population, we have x1, x2, blah blah blah, xn. We have n solution, and of course we know every solution we have x1, x2, blah blah blah, to xd. Okay, we have d dimension. So we pick up randomly two parents. Okay, x1 and x2. So for example, we pick up x1 to become b1, and x2 to becomes b2. So we get the parents, right? Parents. Oh, so here they use n. So n mean the dimension. Okay, capital N mean the number of solution. Okay, and small n or little n mean dimension. Dimension. Okay, yeah. We have two n-dimensional parents, B1 and B2 are linearly combined to produce three different candidate solutions. Okay, C1, C2, and C3 is upstream. Sometimes we say children, sometimes we say upstream. Okay, why we say linear? Because look, this is linear equation, right? This is linear equation. So C1 is B1 plus B2, and C2 is 1.5 B1 minus 0.5 B2, and C3 is minus 0.5 B1 plus 1.5 B2. Yeah. So okay, finally you get three upstream, but we need select two of three, right? Two of three. Why? Because we keep the number of solution in the population. For example, the population had 10 solution. Okay, so we need to fix the total number of solution. Okay, it's always 10. And now we pick up 2 parents. We generate 3 upstream. And then if we keep 3 upstream, that means now we get how many? 11, right? 11. So not good. So that's the reason to from the 3 solution. Okay, the 2 that maintain the best values in terms of the objective function are selected. The crossover upstream. Okay, we need to select 2 and delete 1. Okay, yeah. So this is the ideas of linear crossover. I think it's easy for you to make the MATLAB code. Okay, yeah. And some students in the previous years asked me, okay, why we know for why we choose 1 times bm plus 1 times b2 b1. Okay, 1 times b1 plus 1 times b2, or 1.5 b1 minus 0.5 b2. Okay, it depends on the experience. Okay, this is where yeah, it depends on the experience. Okay, and then the coefficient. The coefficient is 1. That's okay. Okay, or the coefficient is 1.5 and minus 1.0.5, blah blah. Okay, so they are maybe they will be better than the parents. Okay, more opportunity to get um, the good fitness values if we apply the linear equation like this. Okay, of course you can try, you can make a random coefficient. Maybe we have c1 is 2b1 plus 2b2. That's okay, no problem. But you should remember, okay, when we make more coefficients, that means you have more exploration, you know. Okay, we have more exploration. Okay, more exploration, you need to take more times, okay, to get the best solution. Okay, if the coefficient is small, that means we increase exploitation. So you need to make balance between exploration and exploitation. Okay, that is the reason we have coefficient here 1 1, coefficient here is 1.5, and 1 0 minus 0.5, and so on. Okay. Now we go to the second one. Of course, for the homework, okay, you need to make the program, okay, like linear crossover, okay, and like arithmetic crossover. Now we go to the next one. We discuss the second crossover operator with GA, okay, having real parameters, okay. So look, they also select randomly 2 parents, okay, b1 and b2. Yeah, look, b1 and b2 are blended, producing a new solution according to the following model like this. Okay, c1 is 1 minus lambda totally times b1 and then plus b2. Okay, so actually if we go back to the linear, we have b1 let b2, right? Linear. Yeah, linear crossover. Now we have arithmetic crossover, and then we modify coefficient here, right? We modify 1 to become 1 minus Rammer. Okay, and then we keep b2. Okay, so Rammers is in the range of 0 and 1. Okay, why? Because yeah, as mentioned before, they should think about how to balance between exploration and exploitation. Okay, that is the reason Rammer should be in the range of 0 and 1. Okay, that means if Rammer is 0, you get a 1 b1 plus 1 b2. If Rammer is 1, you get 0 b1 plus 1 b2. That means we skip this information from b1. Okay, anyway, so the new solution c1 represents the weighted sum of its parents b1 and b2. Yeah, of course. Okay, yeah. Okay, so now we only have, okay, so now we have the population, right? We have x1, x2, blah blah blah, 2, x10. For example, we have 10 solution. Okay, and then we pick up x1 to become b1 and x2 to become b2, and then we generate c1. Okay, so now we have three solution. Okay, one solution from b1, the one solution from b2, and the new solution from c1. Okay, so we need to compare f b1. Okay, this is fitness value, right? Fitness value is b2 and fitness value c1. We compare fitness values of b1, b2, b3, and then you just pick up two. For example, c1 is a good choice here, and b2 is a good choice here. So now here we need to delete what? We need to delete x1 because x1 is b1, right? And f b1 is not good, so skip. So now we have the new population. So new population we have what? x2 is b2, and then we have the new solution c1, x3, blah blah blah, 2, x10. Okay, yeah. We fix the number of solution in the population is 10. Okay, this is the number of solution in the population is 10. Okay, yeah. Okay, so here we say it's arithmetic crossover. Okay, for example, how can we select the better solution? Okay, it depends on our purpose. This is maximization of fx or mean of fx. Okay, so if we consider mean and then we compare fc1 less than fb2 less than fb1. Okay, and then we are going to figure out the solution to minimize fx. That means we choose fc1 because this is the minimum. Okay, and then continue you to fb2, and when we delete fb1 because fb1 is higher than the other two. Okay, so that means we keep C1 and B2, we delete B1. So for the new solution, each one disappears, and then we have the new solution, C1. Okay, totally we fix 10 solution in the population. Do you understand? Any question, please? Tom, if we have some question from students, okay, please repeat to me. Okay, so if no, we continue. Now we come to blend crossover. We say BLX answer. BLX answer. Why? Because now we have the appearance of answer. Okay. Yeah. So now we consider C1. C1 is 1 minus row times B1 plus row B2. Okay. Yeah. So different from the arithmetic crossover, the values A determines a follow row. Row E what? Row E 1 minus 2 answers, and we have normal distribution used. Okay, a random number uniformly distributed from 0 to 1. Okay, 0 to 1. Minus answer. What is this? That means like random, right? Random. Okay. So answer represents a constant between 0 and 1. Now look. So if, of course, we know a random number uniformly distributed from 0 to 1, that means u 1 and 0 equal to what? Equal to 0 or 1, or between, right? Between U10 is less than or equal to 1 and higher than or equal to 0. So this is the minimum, right? And this is the maximums. Okay. And alpha represents a constant between 0 and 1. So mean is 0, right? And max is 1. Okay. So you can determine rho, right? We can determine rho. What is the range of rho? What is the range of rho? Okay, we can check rho. Okay, here, if mean you get 0. Okay, so 0 times this one you get 0. So you get 0 is minus alpha. So that means rho is minus 1. This is mean, right? Do you understand? Here is 0. Okay, mean is 0. 0 times here you get the 0. 0 minus alpha. And maximum of alpha is 1. So you get rho is minus 1. Okay, so if okay, so if here you get 1, right? Maximum 1. So 1 times minus 1 times 1 minus 2 alpha, you get 1 minus 2 alpha, right? Time 1 minus alpha. You get what? You get 1 minus what? 2 alphas. 2 alpha minus alpha, you get 3 alpha. Okay. So the maximum alpha is 1 and the minimum is yeah. So if alpha is 1, you get rho is 1, right? And if alpha is 1, you get minus 2. Okay, so now we compare. So you can determine the range of rho is higher than or equal to minus 2 and less than 1. So this is the range of, this one is the range of rho. Okay, yeah. So now we can get the range of rho is minus 2 to 1. Okay, so if rho is minus 2, you can get C1 is what? Minus 2, you get 3 B1, right? Minus 2 B2. And if rho is 1, you get C1 is 0 B1, right? Plus 1 B2. Okay, yeah. So it depends on the random values of U and alpha and rho. You can get random new solution C1. Okay, so more randomness. Okay, so blend crossovers is better than the others, right? Why? Because we increase the randomness level of crossover operators. Any question, please? Yeah, maybe correct me if I calculate wrongly. Okay. Yeah. Any questions? Okay. So if no questions, we continue. Yeah. Yeah. Okay. So what is this? That's this. Okay. Here we try to try to determine the mean and max, or this is the lower boundary, right? Lower boundary of C1, and this is the upper boundary of C1. Okay, yeah. The BLS answer produce a new solution in the first dimension. Okay, we just consider the first dimension. Of course, we have C1 blah blah to C1D. We have D dimension. Which corresponding to a random position with the interval. Okay, so this is the lower boundary and the upper boundaries of the fourth dimension. Okay, it is also assumed that B1 less than B2. Okay. Okay, so here they give you this Yeah, these lower boundaries and upper boundaries of C1. Okay. So how can we get this one? How can we get this one? Very easy, you know. So now we know C1. Okay, C1. So C1 is maybe I demonstrate to you. C1 is 1 minus rho times B1 plus rho B2. Okay. And rho is what? Rho is here, right? Rho is 1 minus 2 alpha times u minus alpha. Okay. So if u is 0, yeah, u is in the range of 0 and 1, right? Yeah. So we can get rho is minus alpha. And if u is 1, you can get rho is 1 minus 3 alpha, like this. Minus 3 alpha, like this. Okay. And then now we have C1 is, so this is, you can guess what, 1 minus rho is alpha to u plus alpha is big 1, and rho is what? Right? Rho, and yeah, we are considering, let me see, we are considering this one. If u is 0, alpha is minus, rho is minus, alpha to get 1 plus alpha. Okay, and minus alpha is B2. Okay, so this one's become B1 plus alpha B1 minus B2. Or we modify a little bit, you get B1 minus alpha, and then we have B2 minus B1. Okay, yeah, so we can get this one. So because this one is 0, so this one is lower boundary. Lower boundary, you get B1 minus alpha, B2 minus B1. Okay, so now if we have u is 1, you get rho is 1 minus 3 alpha. Sorry, 0, rho is 1 minus 3 alpha. So you get C2, C1 is what? Okay, so 1 minus rho, that means minus 1. And rho is here, right? So plus 3 alpha times B1 plus rho. Rho is what? Rho is 1 minus 3 alphas B2. Okay, so 1 minus 1 you delete, so you get okay, so here you get B2, right? 1 times B2, okay, minus 3 alpha, you get B2 minus B1. Okay, so you get here. So I demonstrate to you, okay, how to get the lower boundary and the upper boundary. Okay, yeah, upper boundary of C1. Okay, so if we consider the first dimension, one, so you get here the first dimension, 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 like this. Yes. Any questions so far? Tom, so are there any questions from the room? In the room? Okay, so for next, okay, I hope all of students enjoy it. Okay, so now we go to the next crossover. So how many crossover you've have studied? The first one is linear crossover. The second one is arithmetic crossover. Okay, the third one is blend crossover. Okay, and now number 4, XPX. Okay, XPX. simulated binary crossover is were established in 1995. Okay, so these schemes emulate this operation of the one boy crossover for binary representations. Okay, so in XBX, two parents B1 and B2 are considered to generate two new solutions, XC1 and C2. Okay, so we have B1 and B2 pick up from the population, right? X1, X2, blah, 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 Xn, right? We have n solution. Okay, yeah, and then we base on two parents, we can guess C1 and C2. Okay, so in the SPX process, okay, we define the dispersion factors and C, okay, to control the effect of the crossover operations. Okay, so if NC is high, okay, so there is a higher probability that the new solution will be located near the parents B1 and B2. So if NC in re, so C1 and C2 near B1 and B2. So for up to now, we must understand what is the meaning of near, right? Near. What is near? Okay. So near what? Okay. That means we consider the distance. Okay. We consider distance between the children and the parents. Okay. For example, here we have B1, here we have B2, and here is C1. So we have the distance, right? The distance D. Okay, the distance. So if the distance is smaller, that means C1 and C2 near their parents. Okay, so if NC is small, that means C1 and C2 far away from, right? Far away from B1 and B2. That means the distance is lectures and lectures. Yeah, this is the ideas. Okay, and we have the questions. How can we determine NC? How can we set up NC? Okay, how can we know the distance is small or the distance is lectures? Now we look at this one. Okay, so they give us the quasi random factors beta. Okay, you have 3 minutes. Try to understand this one first. Okay, 3 minutes now, please. Okay, sometimes you need to understand for yourself about these lecture slides. Okay, so you can see we have beta, right? We have beta. So beta is the function of NC. Okay, yeah, NC and R. So now they define beta is the function of R and NC. Okay, so if NC increase, that means this ratio decrease. This ratio decrease mean beta decrease. Okay, so if R, okay, what's the R? R is random number uniformly distributed. Okay, 0 and 1. Okay, so R is 0 to 1. Okay, yeah. And then from here, if R is 0, of course, we don't care about NC, beta will be 0. So if R is 1, yeah, R is, this is 1, not 2, sorry. So if R is 1, you can get beta is what? A2, right? And here, you know, R is less than 0.5. So I cannot get 1. R is 0.5. Okay. So if R is 0.5, so you get 2 times 0.5 to the power of blah, 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 right? That means you get 1, right? Maximum R is 0.5. You get 1 to the power of 1 over NC plus 1. So if NC increase, okay, this one is decrease, and now they becomes nearly 1, right? Nearly 1. So if NC is smaller than 1, okay. So if NC is less than 1, so they become 1, right? So if NC is higher than 1, okay, so they need to become 0. So that means beta is higher than 0 and less than 1. Okay, yeah. Okay, yeah. Anyway, we can recognize the range of beta should be 0, should be in the range of 0 and 1, or we say beta belong to 0 and 1. Okay, for example here, of course, otherwise that means are higher than 0.5. Are higher than 0.5, okay. So if here I2 R is 0.5, 0.5, so you get here is 0.5, so you get here is 1, right? 1. So 1 to the power of NC plus 1, okay? So if NC is small, very, very small, it's be, approach to 1. If NC is very, very high, so you get 1 to the power of 0, 0, blah, blah. Okay, so nearly 0. Okay. Do you understand? I hope you enjoy it. Okay. Minus, okay, okay, minus, okay. And because we don't know NC is, because we don't know if NC is positive or negative, okay. So if NC is negative, okay, becomes 0. And if NC is positive, you guess become 1, okay. So 1 minus 1 minus 0, 0, blah, 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 okay. Or that means negative values, negative value. So if NC is negative values, they get 1. That is approaching to 1. To 0. And if NC is positive, okay, beta is approaching to 1. Okay. So now we know the range. Okay, we know the range of beta should be higher than 0 than 1 because of NC and R. Okay, and you should remember if R is less than 0.5, we choose this one, and if R is higher than 5, we should choose betas here. Okay, this is the idea from XBX. SPX. Of course, it's a random values of R, right? R. So once betas is computed, the new solution C1 and C2 are generated. It follows. Okay, so C1 is 0.5, 1 plus beta, B1, plus 1 minus beta B1, B2, and here, okay? Yeah, 1 minus beta here and 1 plus beta here, okay? Yeah, and totally we times 0.5, okay? 0.5. And now we have yeah, and now we have the MATLAB code. Okay, try to understand the crossover operators of SPX. Okay, you have 5 to 10 minutes. Try to run this code. Okay, run this code. Okay, now NC is E2 dispersion. Okay, dispersion factors E2. Okay, and you know this one we just get one dimension. Okay, why we know here it's one dimension? Because look, this is the parent, just get a 2, b2 just get 5. Okay, so one solution has one dimension. Okay, and then we apply this SPX crossover, you know, 1 less than or equal to 0.5, blah blah blah, and then you indicate the histogram. Okay, how many iteration are random, right? Are random number, it does mean are random. So what is this 100? Okay, we repeat 100 execution. Okay, and then you can get the histogram. Okay, histogram, you can observe NC and NCE2 and NCE5. So if NC is higher, that means C1 and C2 near the parents, right? Near the parents. Look, NC higher, near. Okay, look. What's the parents? 2 and 5, right? 2 and 5. So if we consider the distribution of the children, you can see C1 and C1 and C2 near parents, near 2 and near 5. So now where is 2? 2 here and 5 here. Okay, so you know NC is small. So C1 and C2 will be far away from the parents. Okay, so now 5 minutes, do it. Okay, and now you can change. After that, you can change the parents. Okay, the parents is 2 and 2.5. The parents are 2 and 8, and then you observe. Okay, with the same NC. Okay, with the same NC, but we have different parents. Okay, NC2, B1 to B2, 2.5, and NC2, B1 to and B2, 8. Okay, and then we observe the result. Okay, so I think you should have 10 minutes to do this one and this one. Okay, so now 1404 and 1415. Okay, do it. And if you understand as the TA. Okay. So TAs, please help the students if they have any questions. Okay. Okay, so some students asked me to reopen this Google Excel. So I will open until Friday this week. Okay, and then this is the last opportunity for these students. If they haven't registered anymore, that means I understand they rejected to do to the course project. Okay. And actually, I don't know how to reopen it. Let me see. Uh, Maybe later, because now I don't know how to reopen it. Just add TA. Okay. Just add a TA. Okay. Just send an email to TA, and then TA will let me know, and I can update for you. Okay. But now I don't know how to reopen. Let me check. I don't know. Okay. Okay, so I think now some student can register. Okay, so try it if you like to register the course projects. Okay. Now we open MATLAB. Eh? Maybe it's wrong. We should use MATLAB 2024. I did it. Okay. So now I will show you the MATLAB code. Yeah. This one, okay, it's 2.7. I don't have for 2.7. Let me see. 2. This one, the UNDX. Okay, no. 2.7. Let me see whether I have or not. 2.7. Real GIE. Let me check. In my laptop. Okay, fine. Okay, yes, I got it. So here, yeah, you can see. Okay. We set dispersion factors. How many? 2, right? 2. If we follow here, dispersion factor is 2. B1 is 2 and B2 is 5. Okay. Yeah. It's random. If R less than or equal to 0.5, we get mu or beta, you know. Mu means beta. Okay. Yeah. Yeah, and then we get the children. Okay. Yeah, after that we draw these histograms of C1 and C2. save it and run it. Okay. Yeah, and then you can see uh yeah, NC is small. That means we can see the distribution near 2 and 5. Okay, so now we increase NC to be 5. Okay, save it, run it. You can see that that's correct. NC is 5. Okay, more NC increase, so more near to B1 and B2, like the theory. So if you see here, 5 somewhere here is somewhere 5 here, right? 5 here. Okay, and 2 here. So the children, this is the histogram of the children. So children near the parents. Okay, so now if we continue to increase the NC to become 50, yeah, and then run it. You can see, near, okay, very near to the parents, that is 2, and the parents, that is 5. Okay, yeah, so now we understand it depends on the NC. Yeah, and now you look at the beta or mu, mu. Okay, mu is here. Mu actually is we need to calculate mu. So yeah, mu is mu is not in the range of 0 to 1, but near 1. That I think that's okay. Yeah, and R is random number. Okay, R is random number. So we can use the command of ran. Okay, ran to generate the values of R. Okay, yes. So now this is the code for 2.7. So now we continue to talk about here. Let me see that. Okay, so here now we would like to change. We have the same NC but different parents. Okay, so now okay, maybe I cell A's uh, 2.7 new. Okay, so now NCE2 and B1E2 and B2 is 2.5, right? 2.5. Let me check. Yes. Okay, and then run it. You can see here. Okay, 2 here and 2.5 somewhere here. Now B1E 2 and A. 2 and A. Okay, run it. Okay, you can see 2 and 8. So if we change the parents and also the same NC, yeah, you can see see what. Okay, so higher values of parents will be better if we have the same dispersion factors. Okay, yeah, anyway, we can modify the NC okay, to be more suitable with the objective function that we have. Okay, now we continue theory. Okay, Okay. Okay. Let me see. Showing. Okay, so good. And now we discuss about the next one, UNDX. Okay, UNDX operators. Yeah. Let me see. Can you see my slides? Let me check. Okay, good. Yeah. So for now, we discuss about UNDX operators. Okay. UNDX. What does it mean? UN does mean unimodal and distributed operators. Okay, was discovered by this guy, this professor, in the 1997. Okay, requires how many parents? Three parents for producing new individuals. Okay, considering an ellipsoidal probability distribution. Okay, so for normally we just select two parents. Okay, for example, we have 10 solution. Okay, now if we use UNDX, okay, we choose x1, x2, and x3 to becomes the parents. Okay, x1, x2, and x3. Yeah, just randomly, or b1, b2, and b3. Okay, to become the parents, and we can produce the new solution or new individuals. Okay, although the UNDX can be operated with more than three parents, its common use in practical approaches is with three parents. Okay, so in general we have n mu. Okay, n mu. What does this mean? N mu. N mu. So n mu mean the number of parents uh, are randomly selected. Okay, normally n mu is that is 3. Then the mean does considers only n mu minus 1 parents are computed as follows. Okay, so now we can calculate the mean. You know the mean. What does this mean? What does it mean? B over bar. So now we have B1, B2, and B3. We base on B1, B2, and B3. We calculate B mean. Okay. Yeah. Of course, we know how to calculate mean, right? Yeah. So we take 1 minus m n mu minus 3. That's mean if n mu is 3, you get here is over 2. Okay. The summation of I is equal to 2 pi. Okay, yeah. So we just pick up randomly 2 of 3 to calculate b mean. Okay, we can get b mean according to b1 and b2, or we can calculate b means according to b2 and b3, or b1 and b3. It depends. Okay, but remember that when we calculate b mean, just use 2 or 3 parents. Okay, like these formulas. Okay. And then this is the first steps. Step 1, we need to calculate B mean. Step 2, then we need to calculate the direction vectors di for on these n mu minus 1 parents are calculated by here. Okay, we know how to calculate distance, right? From linear algebra. Okay, so distance is bi minus b mean. Okay, so if we have b1, b2, and b3, you can calculate d1 D2 and D3. So D1 is what? This one is B1 minus B mean. D2 is B2 minus B mean. And D3 is B3 minus B mean. Okay, yeah. So when we get D1, you can calculate E1 like this. Okay, this is step 3. Okay, so what is it? This is normalization. This one like normalization. Okay, yeah. You can get, okay, so for E1 is D1 divided by the magnitude of D1, the length of D1. Okay, so we can calculate E2, we can calculate E3. Okay, so for EI corresponds to the magnitude of the vector EI. Okay, with these vectors, one of the S's is built from these ellipsoidal probabilities distribution. Okay, ellipsoid probability distribution. Okay, so now you can get D. Okay, to evaluate the orders orthogonal S's D. Okay, so D is B3 minus B1. Okay, yeah, we already have, right, 3 parents, right? So we take the length of B3 is minus B1 and times this one. Okay, you can get D. Okay, so remember, if we use B3 minus B1 here, okay, so this one must be B2 minus B1. Okay, so if here we use B2 minus B1, so here B3 minus B1. Okay, if we use B1 minus B2, so and then we keep B1 and here we get B3. Okay, so this is the rule when we calculate D. Again, if we use B3 minus B1, okay, so here we should use B2 minus B1. So that means B1 like common. Okay, so if here B1 is common and then we use B2 minus B1 here, so here must be B3. Now B2 is common, B2. So here is B1 minus B2. So here must be B3 minus B2. Okay, so this is the rule when we just the rule for you remember easily. Okay, yeah, we can get a D. Okay, any questions so far? Okay, so this is step 4. Okay, so step 1 we calculate B mean. Step 2 we calculate DI, distance. Step 3 we calculate EI, vector EI, and step 4 we calculate D. Okay, and then we can get the result. Okay, we can get the result. Okay, so now look here. This is B2. We have 3 parents, right? This is vector B1. This is the vector B2. And this is the vector B3. We assume we have 2 dimensions, 2 dimensions, R2, 2 dimensions. 2 dimensions. That means every solution we have x1 and x2. Okay, so we can get B mean. Okay, they calculate B mean according to B1 and B2, right? So B mean is 1 over 2 B1 plus B2. Why I know? Because look at this one. This is the distance from B1 and B2. So this is the mean, right? The mean here according to B1 and B2. Okay, go back to here. Okay, we just pick off 2 of 3 parents to calculate B. Okay, B mean. Yeah, so now you can get, and then we calculate the distance from B3 to B mean. Okay, the distance from B1 to B mean, the distance from B2 to B mean. Okay, and a loss of solution, dot, a loss of dot here, a loss of dot here. Okay, yeah. Okay, around the mean, around the mean. Okay, like this. So now look, this is B1, this is B2. So here should be B mean. Okay, so we have the distance from B3 to B mean, the distance from B2 to B mean, the distance from B1 to B mean, and many solutions. Okay, located around the mean, around the length between B1 and B2, and this one become what? This one become ellipsoidal distribution. Okay, ellipsoidal. Okay, ellipsoid. Okay, ellipsoid, probability distribution. Okay, now yeah, we can run. Okay, so yeah, every iteration. Okay, every iteration you can get a different distribution of the solution. Okay, now continue. We need to calculate C. Okay, this is step what? Step 1. Okay, step 2, step 3, step 4, and this is step 5. Step 5. Step 5. Okay. So once the ellipsoid probability distribution is defined, new solutions are produced according to the following model. Now, what is it? This is a solution. It is solution, right? Solution. So 1 minute or maybe to 5 minutes, try to understand how to generate solution. Okay. Try to understand. Uh, okay, now I explain to you, of course. For here, we calculate CI, so how many children? Okay, we can get, a lot, okay, CI. Okay, we can set up how many children we need. 2 children, 3 children. Okay, so of course we can get 3 children. 3 children. Okay, this is B mean plus what? Plus J is 1 to N mu minus 3. Okay, N mu is what? N mu is normally 3. So this one is 2, right? Normal distribution. Okay, normal distribution. So rho sigma, sigma 1. Sigma 1 is standard deviation. Sigma square is variance. Okay, so how can we calculate sigma 1? We base on this formula. Okay, times distance. This is distance, right? This is the magnitude. Okay, the length or this is the length of a distance. Okay, times ej. Okay, and we know j is what? J is 1 to 2. Okay, now continue. Normal distribution, and this is sigma 2. D, how can you get D? Here you can get D from step what? Step 4. You can get D. Okay, and then E and mu. Okay, N mu is 3, so you can get E3. Okay, so J is what? J is 1 or 2, so EJ mean E1 and E2, but here E and mu, and N mu is 3, so here E3. So if I write here, you can get C1 E B plus what? Okay, J is 1 to 2, right? And 0 sigma 1 square D what? DJ EJ plus N 0 sigma 2 square D E3. Okay, so here J is 1 to 2. Should I analyze this one? I can get what? N 0 sigma 1 square D1 E1, right? Plus what? This is sum, right? and 0 sigma 1 square. Okay, D2, E2. Okay, and then plus this one, right? And then plus this one. You can get children. Okay, children. Yeah, so you can get any how many children we need. Okay, and now you should practice. Okay, you should practice. Yeah, should totally weigh how 5 steps to use UNDX operator. And now we use MATLAB to practice. Okay, so we have 10 minutes now, 14:40, and you will finish 14:50. Okay, do it. And of course, Miss Tom will help you if you have any question. Now, please do it. Okay, so we continue. So we analyze this code. Okay. Okay. Open here. Let me check. I made love. Okay. So yeah. Okay. Let me see. Okay. So for now, this is MATLAB code. Okay. We analyze step by step. Okay. Yeah, so remember that maybe you need to run your MATLAB code first. Okay, and then if are there any problems, you can compare with my reference code. Okay, so now you can see we have and the number of iteration is 500. Okay, B1 is random. This one is random. Okay, so here we have one row and two columns, right? So one rows and two columns. So that means we have two dimension. Okay, B1, B2, B3. Yeah. After that, we plot B1, B2, B3. Okay, we calculate mean. Okay, mean. This is mean. Or we say this one is B overbar. Okay, we calculate the direction, vectors minus vector. So this is vector, this is vector, this is vector. Okay, and then we calculate norm because di over the magnitude of di is ei. So this is norm, or we say length, right? And then we calculate d. Okay, and we generate the children. How many children we need? Okay, it depends. Okay, if we need two, we generate two. If we need three, we generate three. If we get 500 iteration, if we have 500 iterations, so we get 500 children. Okay, and then you can draw the distribution of children. Okay, so run it. So remember that for this one, D is what? B3 minus B1. B3 is minus B1. So here must be B2 minus B1, and here is B2 minus B1, like this one. Okay, they are using this one, B3 minus B1, blah blah. Okay, so for yeah, and now run the code here. Okay, we have B1. That means we generate here. We write something. We generate B1 with two dimension. Okay. And similarly, here we generate B2, generate B3. Okay. Yes. And plot it. Okay, we calculate means. Okay, here is mean parents. The mean parents. Yeah, we just pick up B1 and B2, pick up B1 and B2. Okay. We calculate the direction vectors. Okay, and the direction cosine, or we calculate E1, E2, E3. We calculate norm. Okay. Yeah. T1 and T2. T1 and T2 is what? Okay, T1 and T2 is the formula we calculate C. Here is C. Here is C. So we say this one is T1, this one is T2. mu, right? Mean, right? Means plus T1 plus T2. We just separate C to become three terms: T1, T2, and mu. Okay, just for easy, this one A3, this one A3, this is A1, A2. Yeah, I analyze to use here, no, yeah, sorry, the normal distribution, right? Normal distribution, and then D1 E1 plus normal distribution D2 E2, blah blah. So like this. So okay, D1 E1 plus. Okay. So here you get sigma 1. Sorry, sigma 1 and sigma 2. So sigma 1 is 0.3 divided by n mu is 3. 3 is minus 2, you get 1. So the square root of 1 is 1. So sigma 1 is 0.3 and sigma 2 is 0.35. Okay, so here you get 0.3 and here 0.35. Okay, yeah. So like this. Like this. Okay, like this 0.3, 0.35, and then solve it, run it. Okay, yeah. You can get these results. Okay, so just here. Okay, run again. Maybe it's okay. Yeah. So when we repeat, when we run again, we can get the curve like this. Okay. Yeah. So what is B1, B2, and B3? So B1, okay, B1 is red color, B2 is black colors, and B3 is green color. Okay, so I just copy it, okay, and I analyze to use the copy figures, and I use here. Okay. Yeah. Cannot pass. Let me check. Okay. Just phải copy the figures. Let me see. Or I will print. Okay, yeah. And add here. Pass here. Okay, yeah. So okay, here you can see we can analyze, right? We can analyze. So here, what is red color? Red color is B1. Okay, B1. And here is B2, right? Let me check. Okay, and here B3. Okay, so we get here, you get B mean, B mean, so a loss of solution near B mean, and we can get this eclipse. This one is eclipse. Okay, eclipse, and this is distance from B3 to B mean. Okay, yeah. Then when we run again, okay, you can get different. Okay, this one is more eclipse. Okay, this one is better than this one because the eclipse should be like this. Follow the lane between B1 and B2. Okay, but this one is not good, so we need to run the code again, and then you can get here is eclipse. Okay, yeah. So this one will be better. Okay, or you can run again. Okay, you can see it's a different distribution. Okay, this one is good, like eclipse. Okay, so yeah, this is UNDX. Okay, so if we can get C. Okay, yeah, how many children we have? 500 children. Okay, but when we integrate UNDX rush over into GA, we just choose 2 children. That's enough. Okay, we don't need to get 500 children. Okay, so now we modify the code a little bit. Okay, now here, look. Now I would like to calculate mean according to B1 plus B3. Okay, so at the beginning here we choose B mean, that is B1 plus B2. Okay, B1 plus B2. Now B1 plus B3. Okay, so what is B1? What is the meaning of B1 plus B3? So here we have x1 and x2. Okay, so now we have B1. Now we have B3. Now we have B2. Okay, and then we use B1 and B2 to calculate B mean. So here is B mean, right? B mean and B2 here. So the eclipse should be here according to B1 and B2 distance. Okay, so now go back here, B1 and B2. So we need to modify D. We need to modify D. Why? Because we calculate, for example, reverse one, we calculate the mean between B1 and B2. Okay, so here we need to calculate the difference between B2 and B1. B2 and B1. Okay, now we calculate mean according to B1 and B3. So here we should use the difference between B3 and B1. If here is B3 minus B1, so here's B2 minus B1. Okay, yeah, solve it, run it. And you can see this is B1. This is B1 is red. Okay, B3 is green. Okay, so you get a clip like this. Okay, maybe we run again. We run again for clearly. Okay, not good. Just to run it. Yes, this one is maybe better. This is B1. This one is B3, and this is eclipse. Okay, and this is B2. Okay, yeah. So it depends on your decisions, your programs. You can calculate mean according to different pairs of the parent. Okay, and the questions. Maybe one more to let you understand now. Okay, also B1, but now I use B2 and B3 to calculate mean. Okay, so now I need to modify a little bit. Okay, now the difference. What is the difference here? The difference. Now difference. Okay, I highlight for you here, right? Okay, the difference here, difference. So the difference here must be B2 and B3. Okay, so now B2 and B3. So here B3 is minus B2. So here must be B1. The others must be B1 minus B2. Okay, and we keep the others. Run it. Okay, so you can see now we have B1. B2, this is B2, this is B3, and this is B1. Okay, so the eclipse like this. Okay, maybe one more you can get understand. Yeah, look. Now we consider B2 is black color, B3 is green color. Okay, we consider B2 and B3 to get the eclipse. Okay, distribution. Now B1 here. Okay, just one more. You can see, yes. Okay, this is B. This is B2, B2 and B3. Okay, you want the eclipse like this. Okay, that's correct. Okay, one more. Okay, B2 and B3 and B1 here. Okay, anyway, now we finish U and the X. Okay, any question, please? So far, any questions? Tom, are there any questions from the class? Okay, so we take break. Okay, 10 minutes, and we come back at 3:30. Okay. Tâm ơi cho điểm danh đi Tâm ơi. Để thầy mở lên, sao thầy mở cái ấy không được, thầy khóa nó lại, bây giờ thầy mở không được, là mấy đứa có biết cách nào mở lại không? Để thầy nghiên cứu, thầy mở lại rồi thầy sẽ báo với Tâm hay rồi các em đăng ký ha. Các bạn đăng ký được rồi đó Tâm ơi, kêu các bạn vào Excel và đăng ký được chưa? Nếu các bạn đăng ký không được thì báo với Tâm ha, Tâm lập danh sách xong rồi gửi qua cho thầy sẽ tự nhập vào cho các em. Rồi ha, đang Tâm có thể truy cập cái file Excel để nhập dùm cho các bạn được rồi đó Tâm. Thầy thì giao quyền cho em rồi đó, thử cái được không? Thử cái được không? Đúng rồi. Cái file Excel á, thử coi em nhập được không? Tâm sửa được đó. Okay, we come back. So for now, we continue to discuss selected two, and we hope we can finish selected two today. Okay, so Tom, can you see my slides? Okay. So now we discuss about BCX. Okay, BCX. So BCX means parent-centric crossover. Okay, and this method is very interesting. Okay, and up to now, for many application use GA with this method. Okay, so for the BCX is a multi-parent crossover operation where new solutions are generated around a selected parent. Okay, so yeah, similar to UNDX. Okay, the number of parents is normally 3. Okay, that means n mu is 3. Okay, so that means the population has more than 3 solutions, right? The population we have x1, x2, blah 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 to xn. Okay, and the population has more than 3 solutions. Okay, now n mu is 3. Then one parents from this existent n mu is randomly chosen. Therefore, the new individual CIs is produced near PI. Okay, so now if we pick up 3 parents from the population, okay, yeah, and then we need to calculate B mean. So now B mean is 1 over n mu, and n mu is 3. The summation from BI, IA1 to 3, okay? So this is different from UNDX, okay? UNDX, we have 3 parents, but when we calculate B mean, this is 1 over 2, and then I is 1 to 2 PI, okay? So from 3 parents, we just pick off randomly 2 parents, and then we calculate B mean. We calculate B mean. But for parent-centric crossover, we calculate B mean. According to this one. Okay? Yeah. Yeah. So this is the first step. This is the first steps. We need to calculate B mean. Okay, step 1. Okay. Yeah. The first step. In the first step, the central point, which is the central point for is why? Because this is B1. For example, here it's B1, this is X2, this is X1, right? And this is B2, and this one is B3. So okay, yeah. So you can get the B mean somewhere here, right? B mean. This is the central B mean. Okay. So the first step in the central point B mean, B overbar of all parents is calculated. The second step, a direction vector between the selected parent BI and the central point B overbar is computed. Okay, we can calculate DI. Okay, so similar to UNDX. Okay, this is step 2. Okay, step 1 we calculate B mean. Step 2 we calculate DI direction vectors, and afterward, the direction cosine are calculated. Okay, so here this is step 3. Okay, so step 1 is similar to UNDX, and step 2 and step 3. Step 1 is different from UNDX. We calculate central point, and step 2 and step 3 will be similar to UNDX. Okay, now step 4. Okay, so for step 4, we calculate orthogonal distance. Okay, orthogonal distance. delta j is 1 blah 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 2 and mu, and of course j different from 1. Sorry, j different from I. Okay, j different from I, because we consider j here, so j is of course different from I. Okay, of the order n mu minus 1. Okay, yeah. Parents to the vectors di are calculated. Okay, after that we can calculate the average orthogonal distance. Average. Okay, so delta average E, the summation I j is 1 to n mu 3. Okay, n mu normally 3. Okay, I different from what? I different from j. Okay, I different from j. Okay, delta j divided by n mu minus 3. So n mu is 3 minus 1. Sorry, n mu minus 1, you get 3 minus 1, this is 2. Okay, so when this is step 4, we calculate delta average. Okay, finally step 5. Okay, a new solution is produced by the following model. Okay, pi. Okay, C case, how many solution we need? It depends. Okay, it depends how many iterations we have. Okay, so for bi is the normal distribution time di, the same with u and the x rays, and then here I different from j, or j different from I, blah blah. Okay, so if I modify this one, I can get what? Okay, so maybe I copy here. Maybe I print. Okay, print this one. Okay, and pass here. Okay, yes. Yeah. So now we calculate CK. Okay, case is 1 to the number of iteration. Okay, so CK BI. I is 1, 2, and 3. Because n mu we have 3. So we have BI plus normal distribution 0, sigma 1 square DI. Okay, DI plus, okay, J is 1, J different from I, and mu. Okay, and normal distribution 0, sigma 2 square, and then delta average EJ. Okay, so now if we have B1, we have n 0 sigma 1 square, okay, time D1. Okay, D1. Then this is CK plus what? Plus, okay, J different I, So now I is what? I is 1, right? I is 1. So here we can get J is E 2 to 3. Why? Because J should different from 1, and n mu is what? N mu is 3. So you get 2 to 3. And 0, sigma 2 square, delta average is J. And then if we modify this one, okay, we can get what? Okay, maybe I delete here. We get n 0 sigma 2 square, delta average E2 plus n 0 delta 2 square, delta average, and then E3. Okay, that's all. Now if we have CK, that is B2 plus n 0 sigma 1 square D2. Okay, D2. So here, look, J different from I, so J different from 2. So J is 1 or 3, right? J is different from I. Okay, and 0 sigma 2 square delta average EJ. and this one becomes n0 sigma 2 square delta average E1 plus n0 sigma 2 square, right? Sigma, this is sigma, not delta. Okay, sorry. So maybe we modify a little bit. Okay, sigma, then delta average E3. Okay, so this one does mean IE E2. So based on this one, you can guess solution. Okay, and the last one, right? The last one, C case is one, B3 plus N 0 sigma 1 square D3. That means IE3 plus what? Okay, number distribution 0 sigma 2 square delta E1. Okay, plus 0 delta 2 square delta average, and then E2. That's all. Okay, so every iteration you get how many children? 3. Okay, because we have B1, B2, B3, so we can get C1, C2, C3 according to this one. Okay, so here we can say CK1, here is CK2, and here is CK3. Okay, yeah, so this is the step 5 of BCX. Okay, I hope you've enjoyed it. Any questions so far? Okay, so yeah, now for example, we calculate delta. So this one is similar to delta similar to the u and dx. Okay, so if now we just modify this one. Okay, b mean. Okay, b mean. We based on the b3 minus b1. Okay, and this here is I2, and then we use b mean. B mean. Okay. Yeah, just let b2 out. So if we consider u and dx, this one should be b2, right? Now we delete b2. You replace by b average, b mean. Okay, and here I is 2. So if here is I is 1, I is 1. So here we can, if I is 2, we have b3 and b1. If I is 1, we consider b2 and b3. Okay, here now b3 is minus b2. And if I is 3, okay, here we consider b1 and b2. Okay, yeah. So now we finish 5 steps. Now you can use MATLAB code to simulate. Okay, for example, here, what is it? This is I is 1. I is 1. So here I is 1, that means we consider parent 1, and here we consider parent 2 and parent 3. Sorry, parent. My internet is poor, so yeah. Okay. I erase it, but it doesn't work. Okay. Again, maybe work. Okay, it's not working. Okay, so this is B2 and this one is B3. Okay, yeah. So we need to calculate the distance. Okay, like this. Okay, so to calculate this one, you need to know delta. Okay, when we get delta, you replace to here, right? Delta is what? Delta is J different from I. So if I is 2, so that means you get delta A, delta 1 plus delta 3 over 2. Okay? Over 2. Yes. Yeah. So if we consider 2, you take, you delete B2, you replace to B over B mean. So if we consider delta 1, Okay, so that's here is B3. B3 is minus B2, right? This is B3, this is B2, this one is B2. Okay, this one is B2, this one is B2. We take B1 out. Okay, and similarly, if here is delta 3, okay, you get a B2 minus B1, take B2 out, you write back B3 out, you get a B2. Okay, yeah, finish. Okay, yeah, very easy. So for now, we have 5 steps. Okay, yeah, and we should use MATLAB to simulate BCX. Okay, so you can get here. Okay, if sigma 1 is 0.15, sigma 2 is 0.15, or 0 sigma 1 is 0.35, and sigma 2 is 0.35. So how can we know sigma 1 and sigma sigma 2? Okay, it depends. Okay, it depends how to calculate sigma 1 and sigma 2. Otherwise, you can base on sigma 1 and sigma 2 here. That's okay. That's okay. Yeah. Yeah. Okay, yeah, it's random for you to choose sigma 1 and sigma 2. Remember, sigma 1 and sigma 2 normally either 0 and less than 1. Okay, yeah, now practice. You have 10 minutes practice. Okay, so now we have 15, 33, and 15, 43. Okay, do it. Now we have program 2.5. Try to understand it. Okay. Oh, maybe today we cannot finish lecture 2. Maybe next week. Okay. But okay, no problem. Try to understand BCX. And TAs, maybe you have students to correct the code if they have any problems. Okay.
Bà dậy xong chưa?
Okay. So for now we uh, discuss about PCX. Okay, how to run it. Okay, so for now I will open my code. Okay, I hope it's working. Okay, yeah. Okay, so we analyze the code. Okay, um, now how many solution we need? 300. Okay, 6-1 we 2 0/15 like this one. Okay, and we randomly choose set up parents. Okay, yeah, so here does mean we pick off 3 parents randomly from the population, right? Okay. Here, every parents, how many dimensions? Two dimensions with 2 dimensions. Okay, and similar this one, similar. Okay, now we calculate mean. Now this is central point, right? Because we have b1 plus b2 plus b3. We calculate direction vectors. We calculate direction cosines, right? Cosine, and then we make the for loop. Okay, for loop. Run for loop. Okay. Yeah. And the ran I3. What does this mean? Ran I3. Okay. So if you don't understand, you can type here ran I3. Okay, that means the result will be 1 or 2 or 3. Okay. So if you have ran I3 here, you can get 2 or you get 3 or can you get 1. Okay. So the result will be 1 or 2, right? Or 3. Okay. And if n is 1, n is 1, that means here we have 1. Here 1. Okay, 1. If here is 1, the other will be b2 and b3. Okay. Yeah. So now if n is 1, we calculate d2 and d3. Why? Because I mentioned before, if I is 1 here, so the others will be b2 and b3. So b2 and b3, we need to calculate delta 2 and delta 3, and then we go back here, we calculate delta average. Okay, so here if n is 1, we calculate d2. Okay, if we calculate d2 and then we observe this orthogonal distance, we cannot see b2 because we take b2 out, like I mentioned before. Look, we take the b2 out. Okay, I take the b2 out. If we calculate delta 2, we take the b2 out. If we calculate delta 3, we take the b3 out. Okay, now when we calculate delta 3, we take the b3 out, right? Out. And then here the b2 minus b1, b2 minus b1. Here is central point. Here is central point. Okay. Yeah, I mentioned to you before. And then we can calculate the average orthogonal values like this. Orthogonal, okay. Average, delta average. Then okay, so from now we can calculate C. Where is C, right? And what's a sigma 1? Okay, sigma 1 is 0.15, sigma 2 is 0.15. So here you can get this format. Okay, sigma 1 is 0.15. We said before. Okay, then ran n doesn't mean the random number distribution. Okay, and norm d1. Yeah, you will just follow the formula norm d1. Okay, and here this is the norm norm d2, e3 and e2, e3. Okay, and then similarly if n2 is what? n2 doesn't mean here n2, so we consider b1 and b3. Okay, b1 and b3, so we need to calculate delta 1 and delta 3. So when we calculate delta 1, please remember, okay, delete b1. Okay, if we calculate delta 3, we delete b3. Okay, and then we calculate 0. Okay, and similarly if n3, we calculate n3. Okay, we consider b1 and b2. Okay, so we have d1 and d2. Okay, and then yeah, finish. Run. Okay, yeah. So we have red. Okay, red mean red colors. That means the big one is red. Okay, and K mean black colors. and B3 is green. Okay, save it. Then come back, you can see, okay, we have solution around B1, around B2, and around B3. Okay, yeah, okay. And if you run it again, the same, the same. Okay, but the solution, the central point somewhere here. And now you can get the result. And when we compare with these reference results, okay, it will be nice. Okay, it will be nice. Now we modify. Now I would like to get sigma 1 and sigma 2. They are on 0.35. Okay, 0.35. So maybe I say okay, it is new. Okay, yeah, and then I modify here this a 35. So if the sigma is higher, that means we get um, you get different normal distribution. Okay, will be larger. Okay, the normal distribution, the probability distribution will be larger, will be wider. Okay, now run it and you can see, look, look, because we increase this standard deviation. Okay, so you can get this one. So now if I increase to become 75, oh my god, okay, yeah, you get more exploration. Okay, now run it, you can see, yeah, okay, nearly similar. Okay, so for run again, and we hope we can get a nice picture. Yeah, you can see, the solution will be distributed. Okay, yeah, more random. Okay, yeah. So remember, we need to choose 6 months, normally 0.3 or 0.335 or less than these values. Otherwise, okay, you get the normal rubber distribution with the wider space. Okay, yeah. Then okay, maybe we check delete and run again. You can see, yeah, it will be better. Okay, it will be better. Anyway, so we finish the real parameters, GA with the real parameters with different crossover. Okay, different crossover. Yeah. So how many kinds of crossover operators we have? Okay, so we have BCX. Okay, BCX. We have UNDX, right? BCX is very important. Okay, UNDX is also important, and the other for your reference. Okay, for example, we have SBX is also for good. Okay, BLX. Okay, so for the homework, okay, maybe next week we have the homework, and I will ask you to program uh, to uh, to modify GA with real parameters with four crossover operators. Okay, BCX, UNDX, okay, SBX, and BLX answer. Okay, yeah. So if we use GA with real parameter, okay, we can apply one of crossover operator here: BCX, UNDX, SPX, and BLX answer. Okay, yeah, this is homework. Maybe next week. Okay, next week. Remember, you need to complete your homework. Otherwise, when we do this course project, I think it is not easy for you if you don't understand different kinds of crossover operators. Okay, so for now we have 10 minutes more. So we discuss. Yeah, we discuss a little bit GIE with real parameters with mutation operators. Okay, yeah, mutation operators. Of course, if we consider two binary GIE, we have some mutation, right? Mutation operator. But now, if we consider GIE with real parameters, we have different mutation operator. How many? We have uniform mutation, normal mutation, simulated binary mutation. Okay, yeah. So we have three. So after that, we can stop. Okay, this lesson today. So for uniform mutations, okay, this is the simplest mutation approach for GI with real parameters. Okay, it was developed by this professor in 1996. So we need to calculate children. Okay, children. So we just pick up one parent from the population. Okay, we have the populations, and of course we have many solution x1, x2, blah blah to x10. Okay, so when we finish crossover, okay, when we finish crossover operators, okay, we also keep the number of solution in the population to 10. Okay, for example. Okay, now we continue to apply for mutation. Okay, mutation. So we just pick up one parents. I say the parent solution B1. For example, I pick up X1. So for mutation operators, X1 becomes B1. Okay. And then we apply the formula. So C1 mutation, yield mean uniform, is B1 plus R minus 0.5 times delta. Delta is calibration factors. Okay. You know, this is the vector. B1 is the vector, so C1 is the vector, so this one must be the vector. Okay, the vector. So R is random number, so delta must be the vector. Okay, and delta must be the vectors. Okay, so now for normal mutation. Okay, so we have C1n and mean normal is B1. We pick up one parent and then you plus normal distribution. Okay, this one must be the vector. Must be the vector. Okay, yeah. So how can we calculate? Very easy, you know. So if we have C1 is B1, okay, this is the vectors. Okay, for example, we have two dimension. Let me see C11, C12. So B1 we have two dimension B11 and B12. Okay, so here plus vectors. Okay, so you can get C11 is B11 plus R minus 0.5 times delta. This is scalar, so we take the element plus scalar, you get this element C11, and then C12 is B12 plus R minus 0.5 delta. Okay, you can calculate. We can update for the new element, for the element of C1. Okay, yeah. So if we apply this one, you can calculate the children from the parents B1. Similarly for this one. Okay, and of course we have the like this one. You know, we have two dimension, one dimension, right? One dimension. B1 is one dimension. Okay, yeah. Let me see. Oh, this one we have two dimension, you know. B1 is 1 1. Okay, B1 is 1 1. Yeah, two dimension. So you guess sorry, one dimension. Okay, one dimension, and we get one dimension. So you get the children from uniform and you get the children from normal. Okay, so one solution has one dimension. It's very easy. Okay, yeah, and you can get the result here. This one for uniform. Look, this one like uniform distribution, and this one is normal distribution. Sorry, maybe it's okay. Anyway, this is normal distribution. Okay, and the last one simulated binary mutation. Okay, so we get the children from b1 plus 1 minus 2 times random numbers. Okay, v max minus b1, and here you get v mean. So the key points is how to determine v mean and v max and what is it. Okay, so we need to determine the v mean and v max if the random less than probability. Okay, less than the probability PB, you choose this one. Otherwise, if higher than PB, you choose this one. Okay, so it's random for you to choose the probability. Okay, binary probability. Okay, BB mean binary probability. Okay, normally we set up 0.5, or you can set 0.1, 0.25, blah blah blah. Okay, and we should know Vmax and Vmin. So we define Vmax and Vmin. Vmax mean lower boundary and Vmin mean upper boundary. Okay, yeah, this is lower boundary. This is upper boundary. Upper boundary. Okay, yeah, and then you can get the results. Okay, yeah, upper boundaries, lower boundary. Okay, upper boundary is 3 and lower boundary is minus 3, like this. Okay, yeah, it's a lower boundary, this is upper boundary. Okay, and then you can get the result. It depends on different probability. So if the probability binary probability is 1, this one like normal uniform distribution. So if we have probability is 0.9, so this one like normal distribution. Okay, so as simulated binary mutated, okay, SBX is very important. Okay, for mutation operators with GA having real parameters. Okay, so we should practice program 2.10 and 2.11 at home. Okay, and now we finish, and next week we have the exercise. Okay, we have the method of God. Okay, for this objective function. Okay, we use GA with real parameters, and then we discuss about the topics for the course projects. Okay, and then we study lecture 3. Okay, now we stop here, and yeah, we have 10 minutes more to HTA. To ask Ms. Tam if you have any questions about the lecture today, and then 4:10 p.m. you can leave the room. Okay, yeah, I hope you enjoyed the lecture today. I'll see you next week. Any questions so far? Any questions? Okay, yeah, see you next week. Tâm liên hệ anh Tùng á, để gửi cái video cho anh Tùng. Anh Tùng sẽ upload lên cho mình, cho em. Gửi cái link Google Drive rồi đó. Em đẩy lên Google Drive, xong anh Tùng download về, anh upload lên trên này ha. Okay, goodbye, see you next week.